Hello guys, this is Prime Concept. In this video, we want to consider the image formation when our object is placed between our focal point f2 and our lens. Where will the image be formed and what will be the nature of the image that is formed under this condition? So that is what we want to do. In our previous video, we saw when our object was placed at focal point or at f2, we saw that our image was going to be formed at infinity, or rather we can say the image cannot be seen, right? And we established that the image is real, the image is inverted, and the image is bigger than the object. So in this video, let's consider when the object is placed between the focal point and our lens. When object is between f2 and lens, when the object is between f2 and the optical center, or f2 and lens, where will the image be formed and what will be the nature of this image that is formed, right? So we're going to illustrate that using our ray diagram. So this point is going to be our f2, this point is 2f2, this point is going to be our f1, this point is what? 2f1. I want to place my object between at this point. So if this is where my object is, let's see where the image will be formed. Following the rules, I have parallel line. When this line hits the center of your lens, it comes out through the focal point on the other side, right? Yes. Now, I also want to follow through the optical center, right? Now, when it goes through, now you would notice that my two refracted rays are actually diverging, right? They will not meet at any point. They are separating. So it's obvious that they won't meet at any point around here, and they are not even parallel. So what it means is that if I should take them backwards, I will notice I will get a point behind where the two lines would intersect. So if I do this, I take this backwards, even though I'm not drawing to scale, I take them backwards. So you will see that both of them are meeting at a point somewhere. This is their point of intersection, right? So you now see this is my image, this is my object. So you now notice that your image is actually formed in this case on the same side as your object. So what will be the properties of this image that is formed, and why is it so special? We're going to mention. So the properties number one is that image is formed on the same side as object. So please do not say that your image is formed between 2f2 and f2. That does not really matter. It can be at any of these positions. What matters is that the image is formed on the same side as your what? Your object. And that is one thing that is very obvious. Number two, we can also see is that image is erect, or you can say image is what? Upright. Number three thing we can see is that image is virtual. Image is virtual. So the image formed in this case is not a real image. Why is it not a real image? Because it is formed on the same side as your lens, right? And this is not actually where your rays are. So it appears as if they would meet here. So your image is a virtual image in this case. Number four, you can see how big this is relative to the object. So we can say our image is what now? Highly magnified. So this is very important and very special case to us. So you would see that we considered various positions. We considered when our object was placed at infinity. We considered when our object was placed behind 2f. We considered when our object was between 2f and f. We considered when our object was at f. And then this is the final case, when our object is between f and the lens. So you would see that in other cases, your image was real. So the only case where the convex lens gives you a virtual image is when your object is between your focal point and your lens. This is the only case. Every other case you get what? A real image. But under this case you get what? A virtual image. So this point is worth noting. And secondly, every other positions of image of your object gives you an inverted image. This is the only condition that gives you an erect image. So, and it is under this very special condition that your convex lens can be used as a simple microscope, or you can rather say a magnifying glass. So this is the condition where your convex lens would serve you as a simple magnifier, as a magnifying lens, a hand lens, or you can say a simple what? Microscope. Now, it is from this concept of simple microscope that the compound microscope is built. So I would encourage you to really learn this diagram so that when we get to the concept of the simple microscope, we get to the concept of the compound microscope, you can see that those concepts will be built from what we have learned here. So take note of this very important point. I believe this is really very clear to you. So this is the last location for our objects on the convex lens. In my next video, I'm going to consider the location of image position for our concave lens, which is just going to be one position for that, right? Irrespective of where your object would be. So if you have followed this video up till this point, please do well to hit the subscribe button. If you are not yet subscribed, turn on the notification bell so that you'll be notified whenever I post new videos under this. Thanks for always supporting me. Remember, this is Prime Concepts. Thank you.